Okay, let's start this class. Yeah, today we will focus on signal energy and power. Yeah, uh, those are these goals. And first we will review signal energy and power and signal classification based on power and energy. Actually, those are the things we have already talked about in last class. And then we will try to classify signals into three basic classes according to their energy and power. Okay, before we review signal energy and power, what things can you remember? Yeah, from last class. What things do you? A simple one, like here the energy and power. It is the same with the same thing for the physical thing.
One of the brackets, like in a particular range, and then the other
Okay, yeah. I think so. You remember the equations, I'm right. Okay, yeah. Okay, let's try to. Yeah, this is the signal, the signal energy and the power. Yeah, firstly, you need to know that here the power and the energy actually they are not same with the physical energy thing, the physical power. Sometimes I ask you how much power this force have. Yeah, it's totally different. Yeah, this energy and power is just like a kind of quantity. Yeah, you can see here we can define a total energy for any continuous time or discrete time signal and using this equation, which means from T1 to T2, we just try to add xt together. Try to add the value together, power together. Does make sense to you? Yeah, this we call it total energy, and this is for the discrete signal. And the average power, usually we talk about power, we just talk about average power. The power is just like equal this is total energy, right? Yeah, if you compare this one and this one. Yeah, and the average power is just divide the time duration. Yeah, did you notice that? Yeah, just divide the time duration. Yeah, so this is the definition for energy, like a signal energy and a signal power. And then for this one, this is just some signals have a limited time duration. And this is for the unlimited time duration, like from the negative infinity to the positive infinity. And this is the definition for the total energy for an infinite time, like a signal, continuous CT signals. And this is for the DT signals. Yeah, actually those two. It's same, just the T1 equal negative infinite, T2 equal positive infinite. That makes sense to you? Yeah. Because sometimes, like when you when you represent some signals, it's just from the negative infinite to the positive infinite. And then the average power is just try to divide the time duration. Like since here it is infinite, right? So we need to use the limitation thing. And here, because the t here it just goes to infinity, right? But here, why there is this is 2t? I described that. We talk about that in last class. Why? Here, why this one is 2t? Yeah, because you can see we should the p the equal like the e like divide t2 t1, right? Yeah. So here for this equation the t2 equal what? Positive infinity, right? The T1 equal what? Negative infinity. So this is infinity plus infinity, which means it is 2 infinity, all right? That makes sense to you? Yeah, so we represent this to t, which means 2t limitation t goes to infinity. That makes sense to you? Yeah, the similar with this one. Yeah, here. I have the other question. Do you know why there is a 1? Class 1. Usually, what is this one represent? Why there is a 1? Yeah, for the like a discrete signals, why usually there is 1? Because 0. Yeah, because you can see, when you analyze a signal like a 1, 2, 3, 1, 2, 3, -1, -2, -3. Yeah, usually it is seven numbers. It's not 6 numbers. Yeah, this is just like a because there is a 0 existing. Does that make sense to you? Yeah, so yeah, this one is just like the similar situation here. It's just T2 equal N2 plus 1 minus N1. And this is positive, negative, positive infinity. This is negative infinity. Then we can get this one. Does it make sense to you? Yeah, this is just the definition for the signal energy and power. And then, based on the signal energy and power, we can divide all the signals into 3 different classes. The first one, the class 1, we call it energy signals. Those signals have some features, like the power, the average power should equal 0, and the total energy should smaller than infinite, which means it will have a specific value, like it will not go to infinite like that. Yeah, and this is, we call it class 1. And as class 2, it has the total energy should be infinite, but the power is with infinite average power. The power is infinite. So we call it this power signals. And then other situation will be the otherwise, the class 3. The average power is not infinite, and the total energy is not infinite. Yeah, the other situations. Yeah, okay. Do you remember I talked about this? Why we want to divide the signals into 3 different classes? Why?
The sum you can solve with Fourier series and sum of transforms.
Yeah, that's right. Yeah, because you can see we want to deal with signals, and then we have some tools we will learn later. The like Fourier series, Fourier transform, and you can see different tools is suitable for deal with different signals. But when you use specific tools, you need to know these signals should use which tools, and then you should tell this signal belong to which class. Different class will will use different signals, and you will know why different class will use different signal tools, and we will talk about it later. Okay, let's talk about some examples. Yeah, then given signal xt equals cnt, find like energy and average power. How can we do that? Yeah. Let's try to do it together. How? Give me the next step. Give me the next step. How?
Plug your sum of t into the energy and power equations.
Yeah, use that equation, am I right? Yeah, so this is the equations for the energy, am I right? Yeah, so then put the same, replace xt with the sin t, and you can get this one, am I right? That makes sense to you because the sin t, it is a complex number or real number. Real, am I right? No matter t equal what, and you always get a value during like a -1 to 1. That makes sense to you. So we can get this So we can remove the absolute symbol. That makes sense to you? Yeah, or magnitude symbol. Okay, and then I have already given you. So what's the value for this one? Yeah, even you don't know, like do you remember when you want to like calculate integral and something fx or xt dt, and you need to find what after you need to find a thing after derivative it, and you can get xt, am I right? Usually this is like a regular process you need to do, am I right? But here you don't need to find that. Why? Let me talk about let me ask you sin t power. What's the value? What's the value for sin t power? Power sin t. Huh?
Are you just asking for the fair value or plugging in?
Just the sin t. What is sin t equal what? Sin t, yeah. Usually sin t, what's the duration value? Like the value. Yeah.
Well, plugging in infinity to
The t can be from negative infinity to the positive infinity. Yeah, what is sin t? What's the value for sin t? Maybe some number smaller than 1 or greater than -1. Does it make sense to you? Yeah, because sin t it's just like a, am I right? So the value, this is the value, is always between -1 to 1, am I right? So which means the sin t should be a value greater than -1, smaller than 1. That makes sense to you? Yes, you know this one, am I right? Yeah, and what is the after power? Smaller than, yeah, this one, it must be greater than 0, am I right? Because you have power, you give it the power. That makes sense to you? And then smaller than 1, am I right? Because 1 after power, still 1, am I right? So which means sin t square, sin t like oh yeah, square. It is square of power, square of power, am I right? Yeah, so power, it should be, the value should be 0 to 1, am I right? So if you negative infinity to the positive infinity sin t, which means you need to add on infinite value from 0 to 1. For example, we just define that everyone is 0.5 plus 0.5 plus 0.5 plus 0.5. We just get an average, which means we need to add infinite to 0.5 together. Am I right? That makes sense to you? Yeah. Suppose we just get the average value. And what's the value for this one? If we add infinite 0.5, what's the final value? Yeah, infinite. So this one, which means this is infinite. Am I right? And then let's talk about the power, average power, which means we just try to divide t goes to infinite. Am I right? And then yeah, we just put sin t there, and this equation, you know, do you familiar with those equations? I think this is the base fundamental, sin fundamental thing, and then after we use this equation, and this will become this one. That makes sense to you because then use the first equation. That makes sense to you? Yeah, and then we can get this one. Yeah, we just try to divide this equation into 2 different parts. One is this one, and the other is this one. And then put the 2t here and equal this one. Any question about this equation? I think this one is easy, am I right? Okay, and let's talk about what's this? Firstly, let's talk about this part. How can we calculate this one? Yeah. Do you remember what we talked about in the class 1? And there are some like mathematics review. And if you want to, like this one, like MPT, infinite, negative infinite, and cosine 2t equal, like cosine like 2t equal like 2 sin 2t. Do you remember that? Do you remember? Yeah, we talk about this to review the math. And then you can see, I just, you can see, equal this one, all right? Oh, I forgot.
Yeah.
Yeah, yeah, do you remember this one? Yeah, we have reviewed that. And so here we can use that equation. This one. Yeah, because we just put these two offset, this offset, and this will become 40. And then cosine 2t, it will be it will give you a 1/2, and those here will become 1/80. And this one will be sin 2t. That makes sense to you?
So you pull this on the bottom out, because it's a constant, and then use that on the bottom.
You mean this one? Which
So
one?
like, since it's over 2, you just pull that 2 out front.
Oh, yeah. Because this is like there is no t here, so it's just a constant. You can put it out.
Okay.
Yeah, put it out. It's 40, right? And then you put this thing. The other two, yeah, it is 80. That makes sense to you? Yeah. Okay. And then, yeah, this one will equal this one. Yeah, you just put t here, put negative t here, and finally, this equation will equal this one. Yeah, because the sin negative 2t equal negative sin 2t. Yeah, I think you are, yeah, this is just a fundamental sin equation. And then you can see, you just like add them together, and then it will equal this one. That makes sense to you? Yeah, any questions so far? No? Okay, yeah, then we resolve that one. And this is, if t equal infinite, it will be 0. Yeah, because why?
Because the bottom's gonna get much larger than.
Yeah, that's right. Yeah, no matter this t here, it will always smaller than 1, all right? But here it will go to infinite, which means this part will go very large. And then this value will go to 0. That makes sense to you? Okay. Then let's come, which means we can remove this part because this part will equal 0. All right. So let's talk about this part. And then you can see, what's this? What's this? If t, you can see it should equal this one. Yeah, because which means you have, if there is 1, which means you need to add 2t together. Am I right? So which here it is 1/2. So here is a 2t over 2. If here is a 1, here will be 2t. But here there is a divided 2, so it should equal this one. That makes sense to you? Yeah, any questions so far? Any question? Okay, and then let's talk about that. Let's try to divide it, and it will equal what? We just remove these 2, and it will 1/t, 1/2. That makes sense to you? So which means the power should equal 1/t. And what class? This one. Which class? Let's talk about which class?
It's
Huh?
It's two.
case 2, am I right? Yeah, that's right, case 2. Yeah, because you can see the like energy equal infinite. And the power like a specific one, like a smaller than infinite. It has some number, am I right? Okay. Yeah, how about a sin or a constant, like if there is like a coefficient added, how about that? Yeah. Like for the energy, if you give a coefficient, does the value change? Will the value change? Which means here will equal like a square sin t square or a square cosine t. Yeah. So will this part change? Will this value change? Which means this one should greater than 0, smaller than a power. Am I right? Am I right? So which means you will have a positive number, infinite positive number added together. What's that? Yeah, infinite. So the power value, the energy value will not change. It will be the infinite. That makes sense to you? Yeah. The thing is the power. Actually, you can see if you just add a here or cosine and sin, actually you can see it's the same similar equations we can consider, which means here you just add a constant value as a coefficient. Yeah, actually for the power, you will here is 1/2, and for that situation, and the power should be a power over 2. Yeah, because you can see here for now, in the original question, the a equal 1, am I right? And here you just replace 1 with a square, a like power. That makes sense to you? Yeah, if you use a similar process to deal with it, you will find it. And then those situations are always class 2. Yeah, I'm right. So let's talk about the other one, this one. Okay, for this one, how can we do that? Yeah, we just talk about now. Yeah, and then yeah, this one like the first thing you can think about, we use the equation, am I right? Am I right? So let's try to use the equation. But before we use the equation, yeah, you are familiar with this one, am I right? Euler equation. So we can like convert convert it to the cosine sin. Am I right? So which means we know this one, am I right? The magnitude for the EGT is called this one, am I right? Yeah, this is we will for prepare to prepare we can resolve this problem. Okay. Yeah, you know this one, am I right? So let's try to use equations here, and then which means it will we can write this thing with this one, am I right? That makes sense to you? Yeah, this is just the fundamental equation. Yeah, we use this equation and put xt into this one. All right, we can get this one. That makes sense to you? Any question? Okay, and then what's the value for what's the value? What's the value? Do you know that? Let's ask you, what's the value for this part? This part. We just ignore the like integral, like first initially we just talk about this part. What's the value for this part? What's this? Yeah, you see here. Yeah, you can see here. What is t here? T is for this equation. The t is t, and for this t is what? T like plus pi over 3. Am I right? Yeah, but it's a singular. T, just replace the T with T plus pi over 3, but the magnitude will be same. That makes sense to you? That makes sense to you? Let me write it down. Yeah, we have this one, E equals cosine T. Cosine T plus sin T, right? Yeah, we have this one, right? And then magnitude EGT, like equal, this one cosine T squared plus sin T squared, power, yeah, and then this one is equal 1. Yeah, we have this one, right? And this one you are familiar. And then we replace EG T plus pi over 3 equal 1. Cosine T plus pi over 3 G plus G sin T plus pi over 3. Am I right? Yeah, we can write this one equal this one. Am I right? Yeah, and then we just want to calculate this one. Which this one? Cosine T plus square sin T plus pi over 3. Okay. Yes, this one equal this one, right? Does it make sense to you? Yeah, according to this equation. Yeah, so what's the value for this one? Like cosine T pi over 3 square plus sin T pi over 3. What's the value for this one? Huh? You can see here and here it's the same thing. Suppose we let this one equal what? Equal theta, all right? So this equation can be equal cosine theta squared plus sin theta squared. Yeah, we can. That makes sense to you? So what's the value for this one? Yeah, it just be 1. Which means if this angle and this angle is the same thing, it's the same value, this equation should always be 1. Am I right? Yeah, so which means this part, what's the value for this part? What? Yeah, it will be 1. Yeah, and then you can get this one, right? Yeah, 1, which means 1 multiple dt, you can remove 1. But here there is 1, right? So what's the value? Which means you just multiple, add infinite 1 together. What's that? Add infinite 1 together. What's that? Yeah, infinite. That makes sense to you? Yeah, okay, let's talk about the power. Power, which means we just use this equation, and then we put the we put this one, and then this one we know it is equal 1, right? We get this one. Yeah, actually here it actually write 1 here, but it's the same thing. We can get this one, right? Yeah, and then we can get this one because here there should be 2t. It should be what? What's the value for this one? It should be 1. That makes sense to you? Yeah, because you can see you can remove this. Yeah, it will be 1. That makes sense to you? Okay, so which class? Huh? Are you sure? Huh? Class, which class? Here. Huh? Yeah, it's now the power is now infinite and the energy is infinite. So which class? Yeah, it is 2. Yeah, it is 2. Yeah, okay. Let's talk about the other one, and I will summarize. You will know, those are examples as like a purpose. And for this one, what is the UT function? You know what is UT function? Do you know? Have you ever heard UT function before? Have you ever heard UT function before? We call it the English name is unit function. And that means the UT function is just if t greater than 0, and the value will be 1. Otherwise, the value will be 0. Did you see this before? Have you ever seen this function before? Like if the t greater than 0, and the value will be 1. Otherwise, it will be 0. This is UT function. Yeah, have you ever heard this before?
I think I've heard of it.
Okay.
I understand.
Yeah. This is the UT function. I think we just call it. I forgot the specific name. The UT function, which the UT function, which means the t greater than 0, the UT will be 1. If the t smaller than 0, the UT will be 0. Which means if you draw the figure, it should be like this. Yeah, this is t. This is UT. Yeah, that makes sense to you? Yeah. First, I want to talk about that. Let's talk about this one. Okay. What's the first step? The first step, we just use the equation I give you. I'm right. Yeah. So let's try to use the equation. Yeah. This one is just this function will look like. But even you don't know this one, that's totally fine. And then you can see we just use this one equation, and then we put xt into here, and then it will equal this one. But why there is no why we remove ut here? Why there is no ut here? Yeah, that's right. It's just 1. And then did you notice we also change this one from negative infinity to 0? Why?
It's like,
It was negative and 0.
Yeah, that's right. Because ut is just that function. If it is negative, there is 0, nothing here. So we just change the range from 0 to infinity. And then here, ut, if it is t greater than 0, it will be 1. So we can remove it, right? So then we can because here is a power, so we can get this one, right? That makes sense to you? Yeah. Okay. Let's continue to talk about that. And oh yeah, sorry. Actually, we talked about this in the first class. Do you remember? Like you can after you derivative this part, you can get this one. Yeah. Do you remember? Yeah, and then we can get this one, right? So then this equation we can get. Yeah, you just if it is infinite, it will be 0. If it is 0, it will be 1. Am I right? And now we can get this one, which means it is 0 minus 1. It will negative 1 over negative 2 a, and it will be equal 1 over 2a. That makes sense to you? Yeah. Let me write it down. It will be like this equation will be q over 1 e to infinity sorry, a into infinite, and like a plus 1 over a, like e 0, like that. All right. So we like it will be this is exact. This will be 1. This will be like a 0, and this will be 1. All right. It will equal to. All right. Yeah. So it will be 1 over 2a. Like this. All right. Yeah. Okay. Let's talk about power. Yeah, power, we just the similar process, and we put the xt here, and then we got this one, yeah, the similar thing, and then we, oh, sorry. And because because here, this part equal this part, am I right? Does it make sense to you? Yeah, because this part equal this part.
Yeah.
Am I right? Yeah, so if the t goes to infinity, which means this part will go to what? 0, am I right? So which means you just multiple 0 to a value. That makes sense to you? Yeah, and then you just get 0. That makes sense to you? Yeah. So which class? Are you sure?
It's 3, 0.
Huh? 3? Are you sure?
This is one, this is case.
Oh, okay.
This case one.
This is 1, am I right? Yeah, this is 1. Okay. Actually, the 3, like I said, since the class 3, we at least in this class we will now learn some tools to deal with 3. So the class 3 signals will be very few in our class. Will be, yeah, you will not see very often about the class 3. But you need to know which one will be the 3 class 3. Yeah. Okay, this is class 1. Okay, let's talk about this one. Yeah, this one. Yeah, actually, what's the first step? Yeah, use the equations. Yeah, actually, yeah, this thing, if you draw it, you can see this is just equation. Yeah, and then you use the equations and you put xn here, and then okay, the similar thing. Why there is the u1 will be removed. Yeah, because it is will be 1. Because UN is just like, yeah, you can see I've already given you UN equal 1 n greater equal than 0, am I right? So now we can get this one, am I right? So what's this? What's this? Geometrical series, am I right? Geometrical series, am I right? Yeah, we have reviewed this in first class. Yeah, that makes sense to you? Yeah, so yeah, this one, you write this one, right?
Yeah.
Yeah, geometric series. Yeah, you can use the equation for this one. That makes sense to you? Yeah, and then you can use this equation to calculate this one. Yeah, because you can see this a is 1/9 is smaller than 1. Yeah, and after you use this equation to get this value. That makes sense to you?
Yeah.
Okay. Okay, and then we just talk about actually the power is the same thing. Yeah, because this part is just this part. All right. And the n goes to infinity, so this part will be 0. That makes sense to you? Yeah, it's a similar thing with the next one. So it will be 0. That makes sense to you? So which class? Yeah, class 1. Yeah, that's right. Okay, let's talk about the other one. This one. Yeah, n greater and equal than 1. And what's the first step? Yeah, equation. Okay. This we use these equations, and then we use because here we just I just gave you n to the greater and equal than 1, so you can write this equation like this. That makes sense to you, right? Yeah, because it the small n should go to positive minute and start from 1. That makes sense to you. So then it will this one, and yeah, the similar thing. This is what's it? This is P series. Yeah, we talked about that. That makes sense to you? Yeah. So which means this one should yeah, and this is some like some specific one. If P equal 2, if P equal 4, if P equal 6, 3, blah 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 blah, it will equal this value, which means it should smaller than infinite. That makes sense to you? Yeah, at least you know that. This is for this situation. That makes sense to you? Huh? Some. Oh, this is email. Yeah. Sorry.
The timing of it's like every time we answer a question, it goes off like we won something.
Yeah. Oh, okay, got it. Okay, so yeah, you can see, you can use this equation, it will go this one, right? So at least it will smaller than infinity. That makes sense to you. Yeah, the pi equals 3.1, blah, blah, blah. Yeah. Then for this one, I think it's a similar thing. So this one will go 0, am I right? So which class? 1, yeah, that's right. Then let's summarize what we have already talked about. Yeah, actually, there are 4 sufficiency conditions. Yeah, it has the first signal, finite signal of finite length. If your signal here ft it's a similar thing. Yeah, if your signal like absolute signal equals 0 and your signal and you can say t here, which means your signal is the time duration is limited. Yeah, and then your like signal is a finite signal, which means your signal's value will not go to infinity. Yeah, this is the first signal situation. And then this is second periodic finite signal, like a finite signal, which means your like signal is periodic. Yeah, and a finite signal, and the third one is a constant signal, and your signal is a constant. I think the finite. Okay, yeah, and the first one is like a signal of infinite length that goes to infinity, which means your signal has infinite length, and also that goes to infinity. The value will go to infinity. Okay, this is 4 different signals, and this is the 3 different classes. The class 1 energy signal. What's the features for energy signal? Yeah, energy. I'm right. The finite energy. Yeah, like the energy signal usually it will have a finite energy. And how about the power signal? Will have a finite power. That is you. Yeah, and the class 3, which means it is the otherwise. All right. Okay, let's talk about the first one. The first finite signal of finite length. Which class like this signal will belong to which class?
Class 3.
Are you sure?
It's class 1.
Huh?
It's class 1.
Yeah, you're right. Class 1. Why?
Because the 0.
You can see here. Yeah. You can talk.
Because the f to t 0, which is I just remember being the power is
Yeah.
for case 1.
Yeah, that's right. You can see the ft is smaller than or constant, and it is finite length, which means the power is smaller. The energy is smaller than finite, like infinite. That makes sense to you. So this one should. And how about the second one? Periodic. Periodic signal. Yeah, actually, you can see the first one is just like this one. You can see the value will smaller than the specific one. Am I right? The maximum value will be this one. Am I right? The maximum value for this signal will be this one. Am I right? Yeah, and the periodic, you can see the sine function, cosine function is always periodic. And now even here add the other constant finite signal. Means which class?
2.
Yeah, 2. Yeah, you can see all the periodic signals will belong to class 2. Yeah, you can see this one. The fundamental thing is just the consistent. Yeah. Okay. How about this one? A constant signal. Let me ask you a question. Since a periodic signal is belong to the class 2, the constant signal, I don't know if you ever talked about that. The constant signal, actually, we can consider it as a periodic signal. Do you remember that? Yeah, but the periodic is just like a 1, like a t equal 1, like a every do you remember that? Yeah, so this one is also belong to class 2. Yeah, you can also use the equations to prove that. But yeah, and how about the next one? The next thing, the signal of infinite length that goes to infinite. Yeah, obvious, and which means you're like goes to 3. Okay, then let's talk about more examples. The first one. Yes, this is like a equation, the signals. How about this one? When the t goes to infinity, what's the value for this one? Huh? Yeah, so which class? Which class? Yeah, when the t goes to infinity.
Oh.
Yeah, which class? Yeah, class 3. Am I right? How about this one? A constant. Yeah. Class 2. How about this one? Yeah, periodic. Yeah, how about this one? Actually, let's move about this. Yeah, this one. Yeah, it's class 1. It's just a similar yeah, this one. Alpha is just equal 3. That makes sense to you? It's just equal 3. Okay. And then how about this one? When the n goes to infinity, and what's the value? Yeah. Yeah. And how about this one? X 1 next one n is equal even n 1 is equal to when the value is equal even to 1, it will equal, so it will go to it will like this one. Yeah, even odd, it will 1. This one, and even this one. Yes, what's this? If it is a periodic signal. Yeah, because this one is obviously a periodic signal. Yeah, and how about this one? This one is a little different. Okay, when n goes to infinity, like a positive infinity, what's the value for this one? Yeah, so what's the class? Yeah. And how about this one? Yeah, this one actually, you can see what's the difference between this one and this one. There is a G. What does that mean? Huh? This one? If there is a G, what equation you can use? Euler equation. So which means it is a periodic signal because it can be transferred to the sin and cosine thing. Am I right? So it will be class 2. Yeah. So you can sometimes you don't need to use equations. You can tell if it is a periodic signals. You can use this one and okay. This is a yeah. Don't confuse with this one. With this one. You can see here there is a G, but here there is no G. Which means this you can use the Euler equation to convert it to the sin cosine, but this one you cannot. Okay, and then this is the homework. Yeah, any question just let me know. And the due date should be our first midterm. Yeah, like that day. And one more thing, just a question I want to ask you. You can see the periodic signal should be class 2. And some like finite signals should be class 1, I'm right, this one. And others should be class 3. You can see we talk about actually in microelectronics. Yeah, the Fourier series is suitable for deal with periodic signal. The Fourier transform is suitable to deal with non-periodic signal, which means that class 1 is non-periodic, but it can be dealt with using Fourier series. But class 3 is some more complicated. We can use the other tools. Yeah. Okay, we will talk about continue to talk about this next class. Yeah, so far so good. Okay, that's great.
It's like fine, and then periodic